let's dive in. There's a couple sections that I left out, so there's no way that I can do what Chris promised, which is to cover all, 1.5 million service announcements. I do want to leave some time at the end if there's something that jumps out at you, something that that for a fact that I missed, and you want to talk about that at the end. I want to be able to do that. Okay. So I'm Robert with Amazon Web Services. I'm a developer advocate, and I will be giving you the recap. Now, recap of course, reInvent. reInvent was very different this year. It was for the first time ever. This is our first digital reInvent. We had a huge number of registrations. One of the really cool things about reInvent when we take it digital is that we don't have the physical space constraints. I'm sure a lot of you have been to in-person reInvents, and while there are things that we can't possibly replace with the in-person experience, what we did this time around was really go broad, and we had a huge lineup of video on demand. So anything I mentioned here, by the way, these slides are gonna have these session IDs. And if that slide sounds particularly interesting to you, jot down the session ID and you can still log into reInvent and access that particular session ID. And then you can see that and you can get the session in depth, okay? So first category that we're gonna dive into is compute. Compute. Of course, a lot of people associate this with EC2, therefore it should be no surprise that we're going to be talking about some of the major advances in EC2. We now have the P4D instance, we have Graviton 2 powered instances, we have Mac instances. This is a space that just exploded in terms of feature and service launches this year, and I'll take you through a couple of the biggest ones here. Starting with the C6GN instances. These are general purpose compute instances that are powered by the Graviton 2 CPU. The Graviton 2 CPU is custom designed silicon. It's an ARM processor. Therefore, it's a reduced instruction set processor. Very different from an x86 architecturally. But what you'll find is that a lot of your cloud workloads, whether it's kind of PHP, Go, Node.js, these workloads, or Docker, for example, there's already a huge amount of workloads that support ARM-based processing. They run on ARM hardware. And as a result, you can move those workloads from x86-based instances over to ARM-based instances and see up to 40% price performance improvement over current gen hardware. And that is, so first off, 40% improvement in this space is nothing to sneeze at. Graviton 2 also powers a huge number of other instances that we're going to talk about very briefly here. We also launched Mac instances. This is something that I personally thought I'd never see happen, but I'm glad to be proven wrong. And the reason why we did this is because we heard from developers that there were a lot of shops that were building iOS applications and Mac applications, and managing the build process for those kinds of workflows, managing an environment, a productive developer environment with Xcode, it was just kind of a pain. And you regularly saw customers with racks and racks of Mac minis. And so we thought, well, okay, what if we hook that up to our Nitro system, which is our virtualization system? We could we could bring the same benefits that we had from other EC2 instance types. And this in turn speeds up the development lifecycle. It kind of saves you from having to do a lot of this, this grunt work to make your application and build pipeline and environment as reliable as possible. Again, all the benefits of EC2. If you want to attach elastic block storage to this thing, you can do that. If you want to use FSX for scalable file storage, you can do that. You can use System Manager for configuring and managing patches. One thing to call out here is, though, that these are, I know that somebody's going to ask this question, these are the Intel Core i7 Mac mini instances, right? These are not the M1 instances. We're working on that. They currently support macOS Mojave, which is 10.14, and then we have Catalina, which is 10.15, and we also have Big Sur, which is 11.0 support coming soon. Okay. We also have the D3 and the D3N EN instances. So anybody who's used the D2 instances, this is going to be a huge improvement over that generation, because these are local storage optimized instances. So a single EC2 instance can have up to 336 terabytes of attached magnetic disk storage, right? This is local storage, perfect if you want to string together a bunch of these and build an Uber Lustre cluster, for example. And of course, power improvements, performance improvements, price improvements across the board. So take a look at this if you have storage heavy workloads. We have the G4AD instances, and these are basically GPU optimized instances. They're powered by the AMD V520 GPU, and they use EPYC processors. And this is going to be really good for some of your graphics intensive workloads, whether it's modeling, simulation, machine learning. These are going to offer you a significant price performance improvement over the previous G4 class. We also have another variant of storage optimized instances with the R5B. And what this is going to do is if you're using EBS a lot, you have lots of instances that have extended storage via EBS, you're going to want to take a look at this instance type because it offers much better performance compared to the previous R5 instances, a lot better throughput. You can see here 7,500 megabytes per second of bandwidth and over 250,000 IOPS of EBS performance. So, again, your read and write heavy workloads here are going to just blaze through. Next up, we have the M5Z instance, and this is a variation. I don't know if anybody remembered when we launched the Z1D instance back in 2019. That one was Intel Xeon scalable CPUs, and if you actually look at the spec sheet for that CPU, it's a monster. It's basically an overclocked CPU in the cloud. This is a CPU where you can clock all cores at up to 4.5 gigahertz. And I really like this instance because I used to build computers and overclock the hell out of them, and it was always a challenge, like keeping that thing stable and making sure it wasn't too loud. And it's pretty interesting that we're basically running an overclocked Intel Xeon CPU in the cloud at scale with enough reliability to call it an EC2 instance. So always interested to see new launches in the Z class of instances. By the way, the Z1D instance is still one of the fastest cloud optimized instances. Now, you might wonder, what are you going to do with this? Well, it turns out that there's a lot of software out there, whether it be databases or CRMs, lots of software has these, I think, a little bit about outdated licensing models where they charge per core. And when you have that, having one core deliver as much performance as possible per dollar is going to save you a lot of money. So, if you're in one of those situations, absolutely take a look at the M5Z and the entire Z class of instances. And then lastly, we have AWS Trainium. This is, again, custom silicon out of Annapurna Labs, one of our acquisitions from a couple of years ago. This is custom silicon that allows us to do machine learning in the cloud. Again, it uses the Neuron SDK, similar to the Inferentia chips. Inferentia is for inference, and then Trainium is for training. Now we have the entire workflow. We have optimized training as well as inference when you're actually making those predictions with your models. And it supports all the major frameworks such as TensorFlow, MXNet, and PyTorch, and it's available as a standalone EC2 instance as well as via Amazon SageMaker. Okay, that brings us to the end of compute. Quick check, everything going okay? Do we have any pending questions? Okay, thumbs up. All right, I'm gonna keep going and hopefully we can have time at the end to discuss if that sounds good to everyone. All right?
Yep, sounds good.
In the storage category, we have IO2 Block Express, and I wish the name were a little bit snappier, but actually this is huge. This is basically a SAN in the cloud. Now, if folks here have kind of had to wrestle with SANs, you know that there's not exactly too many options in terms of kind of scaling these things up. You kind of have to pay by slugs of like $50,000. So this is all I can say. There's so much to unpack here in terms of stats and throughput that I will just leave you with the elevator pitch that this is a SAN in the cloud. If you don't believe me, you got to check out the session CMP 205. We also have the GP3 volumes. Sorry, this is just straight up a 20% lower price than GP2 volumes. So I always love these kinds of free improvements that and by the way, we're making these kinds of improvements across the board in terms of all of our offerings. 3,000 IOPS burst, so 4 times higher mega throughput in some cases. And again, what this is going to do is any of your EBS heavy workloads, they're going to just benefit from both lower price as well as improved performance. And again, there are all sorts of different instance types that are also paired with these that I didn't cover earlier, but you can definitely find them.
Just can you go one slide back? Is that
Yeah.
you'll have, so basically I can use a IOP, this IO2. If I have two EBS attachments there, I can just scan that and put this in place without any changes.
Can you attach two EBS volumes in place without any? Is that the question?
The question is, if I have an EC2 connected to two EBS volumes, right?
Mm-hmm.
So one is got the OS and one is got the application and data stuff.
Yeah.
So can I just vanilla swap the application one with this, or it's?
You have to upgrade to a GP3 volume.
Okay, got it. Thank you.
Yeah. All right. Good question. Containers. Okay. So as you all know, when we say containers, we really mean these set of three services here: Amazon EKS for running Kubernetes, ECS for running AWS style API container orchestration, and then Fargate for running serverless containers. Fargate is by far the simplest of the three, and it's the easiest one to get started with. But if you want the bells and whistles, or your organization is into Kubernetes, then we have EKS as well. These are, okay, so we have this set of announcements, ECS Anywhere and EKS Anywhere. And what these do is they basically create an ECS cluster that spans AWS as well as your on-prem data center. This is, again, one of these things that, you know, I wouldn't have been able to guess this, but what we heard increasingly from customers is that they need the ability to use the exact same APIs to manage a cluster that is essentially a hybrid of a bunch of on-prem machines and a bunch of machines that they had, clusters that they had allocated in AWS. And ECS was the missing piece if you're in the ECS ecosystem. Similarly, EKS, again, the feedback that drove this feature launch was basically customers saying, hey, we have Kubernetes cluster. It's not just AWS, it's multi-cloud or it's hybrid. And same story here. We want the same set of APIs that allows you to manage the cluster no matter where it is. We have the Elastic Container Registry Public. Hopefully this doesn't surprise anybody. We've been working on a public registry for a while now, and this is a place where you can kind of securely share container images with anyone. We can also lock them down. You know, the one that probably people know best is Docker Hub, but this is our take on this for and by the way, of course, this works with all your IAM policies and all that stuff. So it's super nice if you're already in the AWS ecosystem. All right, moving on to the serverless category here. So if we kind of take a step back, there's a lot of overlap between serverless and containers, and a lot of debate about you know, which one is better, which one has is the right fit for you based on the kind of application that you're building, what kind of architectural patterns and ops patterns does each one lead to. And what we kept hearing was, you know, they both have their trade-offs, they both have pros and cons, but why can't we just run a container as a Lambda function? We actually got that question a lot, and we got it ever since you know, the early days of Lambda and our container offerings coexisting. So unsurprisingly, we launched Lambda container support. So this basically, you can deploy a Lambda function as a container image. And then we also have the ability to run containers within Lambda. So again, this is basically if you have these workloads that are kind of, you know, you have a microservice architecture, some stuff is a Lambda function, some stuff is container, and you kind of, you're running into some sort of impedance mismatch in terms of how your infrastructure is laid out. This might be able to help you solve that problem and have a little bit smoother of a workflow. And it might also improve a lot of your tooling and your APIs, and your automation scripts and all that stuff. Okay. Excuse me. Another thing I want to mention about this is the way that this is packaged right now is that you can take Lambda function and you can package it either as a container image or as the existing zip format. Both of them work in the exact same way that you would expect. Another much requested improvement for Lambdas is the 1 millisecond billing granularity. So now, before this is 100 millisecond intervals. And what this means is that you now have even greater incentive to optimize your applications because every optimization down to the millisecond level can save you money. We had a number of interesting launches in the database space as well, starting off with Amazon Aurora Serverless v2. And the best way to describe this is basically across the board improvements over Aurora Serverless v1. These are improvements to pricing. These are improvements to spin up. These are improvements to durability. But what you'll basically see is that Aurora Serverless v1, while it was a step in the right direction, we had a lot of feedback from customers that it had kind of surprises in terms of how quickly it was able to scale up elastically and scale down. And so that's one of the things that v2 launches, the Aurora Serverless v2 brings is it feels more serverless, if that's making any sense. But basically, your cluster size is much more reactive to when you specify any changes in your input and output. And of course, as always, you only pay for what you use. We have Babelfish for Aurora PostgreSQL, Postgres. And what this does is it enables Aurora to understand queries coming from applications that were written with Microsoft's T-SQL dialect. In other words, queries that were originally written for Microsoft SQL Server and its variants, they often stray from ANSI SQL and take you into T-SQL land. And you can reuse those same queries now with no code changes. And so this really eases your various migration workloads where your previous database, you can migrate the tables, but then if you have a whole bunch of existing queries that are in one dialect or another, sometimes you'll notice that if you switch database engines, those are going to break.
So is it just the queries or is it the stored procedures also?
It is just the queries as far as I understand, but I can take a note and I can follow up. Do you have a workload that needs support for stored procedures as well?
So where I work, most of them are using stored procedures. So I went and told them I did the mistake. I told them that it does everything, but they'll be a little bit stuck. I think I put my tongue too much. I thought it was even stored procedures. So my mistake.
Yeah, I need to double check on that as well. So let me take an action over here and.
I looked because we had a customer ask for the exact same thing, and there is no stored procedure support that I've seen on any of the documentation.
Okay.
I'd love it. That'd be awesome.
Yeah, that is a good thing. I will double check it. Drew, at the end, let's make sure that we connect so I have your contact information, okay?
Yeah, and Robert, I'll tell you the big incentive you can go and sell it to them, right? Google Sheets has a native connector to SQL Server, right? So then you can do your what if. You have many customers who use Google Suite applications. So you can do a what if to Aurora.
Mm-hmm. You said Google Suite or Google Sheets or both?
Sorry, Google, yeah, both. The
Okay.
Google Sheets, the Excel version of Google.
Yes.
Yeah.
Yeah. You're saying that has a T-SQL connector?
Yes.
Okay.
But it does not have a Postgres or a MySQL connector. So if you enable that, it will basically look like it's a SQL server.
Right. Okay. Thank you. Yeah. Let's connect afterward for sure. Okay. Yeah, and this is just our open source project around Babelfish. You'll see that there's a lot of these projects that we kind of release and develop out in the open. This is increasingly common across AWS because we've gotten a lot of feedback that customers want to be able to see the roadmap before we just release stuff every year in bulk at reInvent. All right, this is going to be a pretty big section, if I remember correctly. AIML. First up, we have Amazon DevOps Guru. This is an ML-powered service. It's a fully managed service that automatically monitors your application and detects issues and provides resolutions. And you don't have to configure this at all. You don't need to know, you don't need to be a machine learning expert. You don't need to train your own models. That's what it means when we say fully managed. It's a complete turnkey solution for improving the availability and preventing downtime for your application.
So if you have a model and you deploy it and you have a drift, it will catch it.
So this is for this. Sorry, just to be clear, this is DevOps Guru for general applications, not just ML applications. There's actually another service that detects model drift that I'm not sure if there's a slide for, but we can talk about that afterward.
Thank you.
Yeah. So again, with DevOps Guru, no configuration or ML experience needed. It's fast to set up, easy to use. It automatically detects a lot of different common application issues. Whether this is kind of like connectivity related, whether it's configuration related, whether it's roles and access related. It provides lots of a library of solutions to kind of help you resolve these things. And really, it's kind of for companies who need this kind of, they're clearly have an identified need of a DevOps organization, but they just can't grow to that size yet, or they want to make more out of their DevOps engineers. We also launched Lookout for metrics, and this is a pretty broad service. We're going to spend a little bit of time and dig into this one. So the thing that we notice is that there are a lot of organizations across these different industries that are trying to improve their efficiency through automation. And that sounds like it's pretty generic, but we've been at this for a long time, and we know that one of the things that really makes this happen at scale is the ability to detect anomalies and more accurately react to them. So what Lookout for Metrics does is it uses machine learning to automatically detect and diagnose anomalies. So if you have a graph of data, let's say it's like CPU usage or it's disk usage or it's network IO, you'll see regular patterns in your usage, right? Maybe your patterns for your service fluctuates by the day, by the season. And chances are you have some alarms that are set up that really kind of say like, this is the normal operating range for this metric to fluctuate within. And then you might, these might be handcrafted, but what you want to know is anything that brings you out of the normal operating range, you want somebody to look at and make sure that this is something that you expect and is okay, because in the worst case, it could be a SEV, right? And so this is a really common workflow that we see customers employing all over the place. But with metrics, we know that we can integrate this with a whole bunch of different popular services. So with just a few clicks, you can have Lookout for Metrics hooked up to S3, to Redshift, to RDS, even third-party applications like Salesforce, Zendesk, Marketo, and you can start monitoring metrics. So if you think about the Marketo case or the Zendesk case, right, you now have the ability to use Lookout for Metrics, do automatic ML-powered anomaly detection for things like support case volume, right? And it basically takes, if you have any existing data, it will use that to establish baselines. But if you don't have any existing data for it to kind of ingest, then it will establish that as the data comes in. And it also, in case you're wondering, it also ranks these anomalies in terms of severity. So it has various confidence intervals for knowing whether or not an anomaly is a false positive. So it can also rank that for you automatically to make sure that when you look at this thing, it's as high signal to noise as possible. And it comes, I mentioned a lot of the services that it integrates with. It actually comes with around 25 connectors for different data sources and applications. And I gave you a couple of examples above, but you can take a look at the session EMB 032 if you want to see this thing in action. So this is just a diagram of some of the services that we can integrate with on the left side. And then it uses the same alerting mechanisms that you're already familiar with, whether that be SNS, whether that be a Lambda function or a webhook. And the way that this works is that you get started by creating a detector, and you define the metrics that you care about. So you basically can choose. By the way, these connectors come with all of this stuff pre-configured. You're not actually doing this from scratch. This is all just a couple of clicks. And then when everything looks good, you activate the detector. And as I mentioned before, sometimes you see a graph like this, and maybe the blue areas here are kind of normal operation, normal daily fluctuations in, let's say, daytime usage versus nighttime usage. And if you saw a graph like this and you're on the ops team, you might start to get worried, right? Because you have two flattened humps here that indicate that the curve is not where it's supposed to be if this were a normal day. But if all you had done was kind of set an upper bound to not exceed then you might not detect that. Sorry, I'm going to stay on this slide here. But this is the kind of graph, this is the kind of data that Lookout for metrics can help you detect automatically and make the entire operation process a lot more mature. Like I said, it's not limited to just the mechanical metrics of CPU, network, I/O, things like that. With our connectors, you can also integrate this with, I think I have some sort of auto timing thing going on with my PowerPoint deck. I'm sorry about that. Yeah, so long story short, what Amazon Lookout for metrics and its attendant connectors can do is monitor a variety of different graphs, whether that be in sales, marketing. Okay, it really doesn't want me to stay on that slide. I'm sorry, we'll move on. We also launched a series of these machine learning integrations with other product suites. The common thread behind this is that we wanted to make machine learning more accessible to customers who are more used to working in other parts of AWS. So for instance, let's say you are working in Redshift most of the time. A lot of these ML features are kind of at arm's length for you with this announcement, Redshift machine learning. So what you can do is you can create and train ML models. You don't need any prior experience. And often you can invoke these models and take advantage of the benefits of machine learning without leaving any sort of familiar workflow that you're already used to. And again, rewinding even further back, one of our most important missions over the last few years at AWS is to make machine learning more accessible to everybody. We want to make these services as intuitive, as easy to use as possible. No knock against machine learning experts. Of course, they're extremely valuable. There's just not enough of them. And we've heard from customers all over the world that they just can't hire quickly enough. There's not enough people to go around, right? So when you see us launching these features to kind of make machine learning easier, more accessible, more intuitive, that's really the root of the problem that we're trying to get at. We think that the things that AI and ML enable are so powerful and so game-changing that every AWS customer should have access to these and should be able to apply them to their businesses and see the benefits. Similarly, Neptune ML, and we have these for a number of other databases. I just thought that this, we make the point sufficiently with 2 slides here. But we have, sorry, the learn more URL is wrong, but if you just search for Amazon Neptune ML, you'll find this. But if you're using Neptune, again, I know that Neptune is one of our newer databases. This is our graph database. But what you can do is, again, you can automatically select and train ML models for your graph applications. You don't have to have any ML experience. And if you're comfortable working within Neptune, you're comfortable using Gremlin as a query language, then you just stay in that workflow and you can take advantage of a lot of the power of our machine learning integrations without leaving Neptune. All right, this is a bit of a weird section. I know it's called management, and it might not be what you expect, but here we go. First up, we have AWS Proton. This is a service that that allows you to kind of have a big picture of how all your different microservices and containers fit together. I know we've been talking a lot about modernization, modern app development, kind of breaking down your monolith into microservices, whether that be containers or serverless. But one thing that happens is that adds a lot of cost and complexity on the operations side, right? You know, monoliths, whatever their negative qualities, we'll call them, they're intuitive to deploy, right? It's just one workload, one application. You scale it out horizontally, you clone it into a fleet, and there you go, right? I mean, I'm kind of oversimplifying a little bit, but you know, when you build modern applications that have a more of a distributed backend, it's not so simple anymore. When you look at the architecture diagram, it becomes clear to you, like, oh wow, there's actually a lot of different moving pieces here, and what kinds of dependencies they take on one another, what units need to be deployed together. What units have API breaking changes, what the downstream impact is, what the blast radius, if any, one change. That all starts to become very important for maintaining business velocity, right? But, you know, what we heard was, okay, great. Like there are some customers that you give them the tools to break apart the applications. That's all they need. And then they have the rest of ops figured out. They have a really mature ops team and they can do all this stuff. But that's not every customer, right? What we heard repeatedly was, okay, well, great. Now all I have is this microservice that does this one set of things, and I don't know how to debug this thing. I don't know how to deploy this thing atomically with its 3 dependencies, for example. And so AWS Proton is kind of our take on this. It's the first fully managed application deployment service for containers and serverless applications. So what you can do is you can use Proton to connect and coordinate all these different tools for provisioning infrastructure, for deploying the code, for monitoring, for updating. And you can use this to kind of stay sane while maintaining fleets of hundreds or even thousands of microservices that with constantly changing infrastructure and resources underneath them. And the way that this works is that in Proton, you would create a stack. And this stack defines everything needed to provision, deploy, and monitor the service. So you basically log into the Proton console, you use these published Proton stacks, and your team can publish these, of course. And you can quickly deploy your application code as part of this stack, including all its dependencies. So what this means is that instead of spending a lot of time kind of getting the infrastructure set up for your first deployment, the team can centrally manage these deployments without really impacting productivity. And then these stacks, of course, they can be modified. You can take variants of them. You can do blue-green deployments. You can deploy pre-production environments. But this is basically, I think it's tackling one of these seriously under-addressed areas of the DevOps space recently. Okay, Cloud Shell. I have to say, if I chose one announcement from reInvent this year that I'm personally most excited about, it is Cloud Shell. Cloud Shell is command line access to your AWS account. It is first and foremost free, no charges whatsoever. Okay, and when you log in to Cloud Shell, you can do this today, by the way. When you log into Cloud Shell, you will have your account credentials loaded into that environment. So if you make, STS get caller identity, that'll be you. And you don't need to do any more configuration. You don't need to mess with a doc credentials file. You don't need to mess with AWS profile or anything like that. It is ready to go for you to make API calls via the SDK directly. The second thing is that you have a directory within it where you can install software, you can add settings, you can do add your vimrc bindings, and that travels with you wherever you go. right? So anytime you launch the Cloud Shell, it's just there, it's ready to go. It's going to give you the environment that you want. It also comes with a lot of really useful tools right out of the box. Now, one thing that I tried that I'm sure you will all try is to install Docker on Cloud Shell. Doesn't work, but I'm happy to be proven wrong. If it works, email me, message me, whatever. I really want to see how you did it. But yeah, I would expect that something like that would not exactly work. Well, the other thing that's really cool about Cloud Shell is that it actually includes these common runtimes. So it includes like the AWS CLI, of course, it includes the ECS CLI and the SAM CLI. So if you're working with ECS a lot, if you're working with SAM CLI a lot, before you switch machines, you're like, oh great, I gotta go install Python, and what version of Python is it? And then you gotta go mess with your environment variables and your credentials file, all that stuff all over again. Cloud Shell is just a great way to just have all this stuff all in one place. It has all, it has Node.js, it has Python, it has a lot of other utilities that if it's not pre-installed, you can install them. And this is all running on top of Amazon Linux, Amazon Linux 2, basically. By the way, in case you're wondering, the persistent storage is 1 gig, so not huge, but plenty for doing some lightweight dev work. I really encourage you to check this out. For me, this is a game changer. We have Amazon Managed Service for Grafana. So those of you who've used Grafana or have heard of Grafana, you might know this as kind of a visualization framework for your analytics backends, whether it's Datadog or Splunk or New Relic. You can basically connect Grafana on top of that data, and you can get lots of visualization. Because the reality is, you can gather all this data, but if you can't generate business insights out of it, then really what good is it, right? It's just sitting there costing you money. Perhaps in the worst case, it's a liability because it has sensitive information inside of it. And so it's, we know that the data is oil, but oil needs to be refined. So you have to use something to kind of trawl through the data, turn it into a form that is consumable. And Grafana seems to be emerging as one of these tools that is leading the pack in terms of popularity, flexibility, efficiency. And so this particular project is based on the open source Grafana project. And it comes with a lot of interactive visualization capabilities that are like pre-built dashboards that you can use to monitor, again, metrics, logs, traces, including, the aforementioned problem where you have API calls hopping from microservice to microservice to microservice, and you need to correlate them somehow. There's lots of tools in the Grafana ecosystem that can help you do that. And you can also benefit from kind of built-in capabilities from Grafana, like single sign-on, so that you can manage who has access to the data and the dashboards. And it natively integrates with a lot of different AWS data sources that provide plugin. For example, AWS TimeStream, our time series database. Okay, we also launched AWS Fault Injection Simulator. As the name implies, what this allows you to do is inject faults into your environment. Why do you want to do that? Well, it turns out that production issues are notoriously tricky. And often they come from things that you would have never guessed in terms of, maybe a particular cluster is running at extra high latency, and you used to depend on synchronous replication, and it's going to have all sorts of downstream impact. Maybe one particular node in your control plane is unreachable, and the service reacts in an unpredictable way. Really, the philosophy that we had, and if you watched Werner's keynote during week 2, I believe it was, at AWS we have this philosophy that everything breaks. It's only a matter of time, and so this idea of chaos engineering, of kind of how do we build the service to react to these organic and unpredictable failures, is kind of in the DNA of how the company works. And as a result, we can see that we've always had tools that kind of injected these kinds of faults into our services internally. But we've been hearing for a long time that customers that are on top of AWS, they want to have these same capabilities. So that's years ago we started working on basically what would this look like, and now we have this fully managed chaos engineering service. And you have control over a lot of different things here. So anybody who's been on kind of a game day simulation of how your services go down, you have lots of different knobs and dials in terms of like taking down a region or taking down a cluster or taking down a particular service or even taking down a VPC. Before it was very difficult to do this, right? Because what you tended to do was to wrap your service within some sort of proxy layer. That way at the software level, you can inject these faults. But the problem with that is, of course, that if you run game days by relying on service extensions, you can develop a false sense of confidence because, again, the failure in the real world doesn't actually resemble that, right? For example, if you want to shut down network connections, if you shut it down at a proxy layer, your TCP connection might fall away. Whereas in the real world, that connection might just sit there and fail to react in time, right? So lots of things that this can do that can kind of give you much more real world confidence in how your system is going to react in the face of unpredictable infrastructure issues. The other thing that this provides in terms of benefits is if you can get rid of that proxy layer, your services are also a lot more secure, right? Because you're not deploying code that can potentially be exploited. So any sort of fault injection, if you can do that at the control plane, you can do that at the infrastructure layer, that's code that's not polluting your application. We also have code guru updates, the most significant of which is that we now have Python support. Prior to this, we had Java support. And the team is also looking at a number of different languages that we can add in the near future. I promise you, TypeScript and .NET are fast on their way, but it'll be ready when it's ready. Along with this, we also have improvements to the security detector. So Code Guru can now highlight lines that are security vulnerabilities. So if you're using a web API, you're configuring cores, you can kind of review some of those things for you and kind of point out the most obvious problems if you're doing that. Memory profiler as well. We had this for the Java version, but now this is available with Python support. Amazon Location Service. This one's a doozy. Basically, we now have we've launched a mapping service, and this is basically programmatic access to high quality map data. I think we have some stats that show that it's more cost effective than competing mapping products that I'm not allowed to name. It has a lot of security and privacy features built right in. So location services, of course, at the core of so many different modern services these days, whether it's autonomous vehicles, food delivery, drones, you name it. Almost everything relies on some sort of location awareness these days, and having that access available and integrated with AWS, I think, is a pretty significant step forward. All right, if you're a mobile developer, this section is for you. First up, we have the Amplify Admin UI. Amplify, of course, for some context, is our one-stop shop for building serverless web and mobile applications. And with the Amplify Admin UI, you now have the ability to do even more while writing less code. This can basically give you a lot of ways to manage your user pool, for example, your Cognito user pool. It works with the Amplify CLI. It has lots of dashboards to kind of track what the status of your application is, how deployments are going. Overall, a huge set of improvements that used to kind of have to be cobbled together via scripts. The Amplify CLI with containers. So, Amplify, the typical Amplify workflow is that you deploy an AppSync backend. AppSync is our GraphQL as a service offering, and backing that would be something like DynamoDB, and typically all the connectors and the resolvers in between are serverless, right? But there's a lot of cases where you want to be able to deploy something with a little bit more logic, or something with larger application sizes, application images, for example. And what this can do is you can basically have your developers deploy GraphQL and REST APIs and host websites using Fargate, in addition to the existing AppSync APIs. And you just run, so like all the other Amplify options, you just run Amplify configure project, and you'll see a number of options to do this. So you should see an option in there. It's called container-based deployments. And I think if you drill into that one, it has all the settings for how to get this set up. Like I said, it's GraphQL and REST, and the CLI also, it's worth calling out with some of the stuff that's always done, which is that it's had the ability to manage your VPCs, your subnets, your IAM policies, a lot of other security and infrastructure practices with zero prior knowledge of AWS. And that's really kind of the killer feature, right? If you remember back, harken back to your early days of using AWS, you remember that alarming first thing that's like, stop using your root account, disable your root account, go and spend 12 hours learning about IAM policies, right? Everybody who uses AWS has been through that experience. And then right after you learn about that, you're like, okay, well, now it's time to learn about VPCs and security groups. Those are extremely powerful and important primitives for using AWS. But what I really love about Amplify is that it enables a whole type of developer to get started on AWS without necessarily consuming those concepts up front, right? Those concepts are always there. They're always powerful. They're always flexible. But you can always ease into that. And what Amplify lets you do is operate securely before you're ready to consume those concepts. So Amplify, absolutely on fire in terms of their developer-focused releases here. Sorry, honey. All right. Now we are at the sustainability section, which means we are nearing the end. This one really is kind of a review of the work that AWS has been doing in reducing our carbon footprint. For a long time, we've been committed to running the business in the most environmentally friendly way possible. And we have some data that shows that AWS's infrastructure is more than 3.5 times more energy efficient than on-premise data centers or typical enterprise data centers. And this is due to a variety of reasons. A lot of this advantage is attributable to the fact that we have more efficient server configuration and much higher server utilization, right? So all those data centers that a lot of these enterprise data centers, they still need to run power, they still need to run cooling, regardless of what the utilization is. And that fluctuates a little bit, but there's going to be loss at either end. The other thing is that AWS data centers are also a lot more energy efficient because we kind of designed the whole thing holistically. And then when you factor in kind of some of the continued investments that we can make in this area, whether that be to how we deal with redundant power supplies, what materials we select when we build out the foundation of the data center itself, these all add up. And so what this means is that the net carbon footprint for the same server performance in AWS is 88% lower than the median of surveyed enterprises. Quite a margin, quite a big margin. So what I think is really interesting is that now operating in AWS is a way to meet your carbon footprint reduction goals for your company. And that's actually something that I think we haven't talked enough about. You can kind of team up with us and take advantage of all the infrastructure improvements that we're making continuously to reach your own carbon reduction goals. And AWS is now the largest corporate producer of renewable energy in the world. And we've enabled over 6.5 gigawatts. Apparently, I can say that Werner said this. So with that, we are at the end of our recap. Unbelievable. I'm at 50 minutes. We covered a lot. My intent was to do this in under an hour so that we had time to talk. I want to hear your thoughts. I want to hear your feedback. What's interesting, and we can always open up the slide deck again and drill deeper into any particular section that we want to talk about. So if you're recording, I think this might be a good place to stop.
Yeah. So Robert, speaking of that slide deck, will we have access to this deck?
Yes. So this is
I'm just asking. I'm asking on Chris's behalf because I need to speak for him.
Oh, thanks.
Yeah, I'm going to try and get you a version of this deck. Currently, I'm not ready to share it, but I understand that these recaps are very important for everybody to have access to. So.
Awesome.